So this is combining the combined gas law and stoichiometry. So this is just two things you already know how to do, but we're just combining them together to be able to solve a particular problem. So it wants to know the volume of a gas. So it wants to know the volume of CO2. So we're trying to find this volume in liters of CO2. Okay, above the CO2. And so we know that the conditions are at 200 degrees Celsius, which we've got to change to Kelvin, and it's at 140.3 kilopascals is the pressure that this reaction is. Okay. So before we find liters, what else do we need to know about CO2? So what other quantity do we need to know about CO2 before we can find the volume?
Do we need the moles?
Yeah, you need the moles of it. So then ideal gas law says PV equals nRT. So we have the pressure, we have the temperature, but we can solve for the moles so that we can solve for the volume. And we solve for the moles doing a stoichiometric problem. So what we have is we have 35 grams of this. So then we've got to find the moles of it. So then we've got to find the weight of Al2CO3 free. So we got 2 aluminums times 26.98. We've got 3 carbons, 12.01. And we've got 9 oxygens, 16. That's 144. That's 36.03. And we've got, what is it? 53.96. So we got 9, 9, 13, 13, 233.99. So then somebody find the moles of how much we have of Al2CO3. What's it?
Divided by
35 divided by that number. So how many we got? 0.1.
0.149 or 0.150.
Okay, 0.150.
Sorry.
No, that's okay. You're just thinking. Okay, what's the next thing we need to do? We need to balance it. I don't think it's balanced, so we've got to go ahead and balance it. So what would it be balanced? This is kind of the challenge one, really, the balance, but maybe not. So on the right side we got 5 oxygens. On the left side we have 9. On the right side we have 1 carbon. On the left side we have 3 carbons, and aluminum's balanced out. So which of the two do you think we should balance, oxygen or carbon?
Probably carbon. Because it's only
Okay, so that's what, 3 there?
Yeah.
And then it balances. I thought it would be tough, but it's not. So you guys know what this is supposed to be, right? Without plugging it in. How many moles do we have? 0.45, right? It's 3 times as much. So now we have the moles. And now we can plug in to solve for volume. That's what we want to solve for. So volume equals N, which is 0.450, R, which is kilopascal, is 8.31, and T is what? 473. Divided by P, which is 140.3 kPa. And that should give us our volume in liters. So that's connecting, really quick, that's connecting two ideas where you do some stoichiometry and you figure out a volume. Sometimes you might be given a volume and you have to figure out the mass of a certain reactant that you needed that would be a solid. And you kind of would work it backwards on that type of thing. And so we would end up with 12.6 liters, right? So that ends up with 12.6 liters. I might have you guys do a little lab that I thought of doing a lab with the regular chemistry class, and I think I'm going to try to attempt to do it with you guys and see if you can do it on Monday. I think it's kind of an open-ended lab, and it's kind of a fun lab to do, and I think we need to get to that point where we might be doing a lab or two on this. So, all right. And then the last thing, it's called a limited reaction. So you guys like limited reactions, right? Yeah, you do. Good old ice. Okay, so here's one I'm going to give you, and you got to figure out which one, how much product is produced. Okay, so I'm going to go C3H8 plus O2. This is propane burning. And you're going to make CO2 gas plus H2O. So, what I'm going to do is I'm going to ask you how many moles of CO2 is produced from the reaction, from reacting so 20 grams. Nope, I'm not going to do grams. .4 liters of C3H8 with 15 liters, 15.2 liters of oxygen at a pressure of 1.3 atmospheres and 45 degrees Celsius. Okay. So it wants to know moles of this. And you're given liters. You're given 15.2 or 3.4 of this and 15.2 of this. Okay, now I'm going to tell you that mole to mole works the same as volume to volume. So if the mole to mole ratio comparison is the same as volume to volume, it doesn't matter. If they're at the same temperature and pressure. Okay? So you still use ice the same as what we did before. Initial, change, equilibrium. Now you might not need the E on this ending amount because it's not asking for leftover. But one of these two is going to be excess and one's going to be leftover. So what's the first thing you have to do on this to start the problem solving? Balance it. Yep. So what is it balanced? Anybody have it balanced?
C3H8 plus 502.
Plus 502?
And then 3 CO2 and
3 and 4?
Yep.
Okay, now we're balanced. So now what you've got to do is you've got to decide which one of those two is going to run out based upon what we did with ice in the past. So, which one is limited? Oxygen or C3H8? So you don't have to do anything with this, right? This is 3.4 liters. And so in brackets it would be 3.4 liters. And down here it's 15.2, but would it be used when we go ahead and figure out to be able to compare them directly? 3.04, right? So you guys know which one limits it, right?
So it'd be oxygen.
Oxygen limits it. So then you guys can do a volume to volume 5 to 3 with the 15.2.
Wait, 5 to 3.
Because the volume ratio works the same as a mole ratio. So what you can do is you can take, since we know that this limits, the oxygen limits it because it has less, because after you divide it by 5, it would be 3.04. So then you take the 15.2 liters of oxygen, and then you go, for every 5 liters of oxygen, you have 3 liters of CO2 produced. Okay, so then divided by be 9 something, right?
9.12.
9 point what?
12.
12 liters of CO2. Now, we're asked to solve for moles. So then PV equals nRT. We're solving for N. So PV over RT equals N. So our pressure is 1.3 atmospheres. Our volume is 9.12 liters of CO2. Our R is 0.0821 since it's atmospheres. And our temperature is 373, 313, no, 318. 318 Kelvin. And then,
Do we have to have the values of R memorized?
no. You will, maybe by the end of it. You got 8.31 and 0.0821, so they're really close.
Wait, but isn't there a third one?
And then 62.4. Actually, it's 62.414. If you want to get all the way to. No, I give you all that.
Okay.
And they give you that on the AEP test too. They give you all the formulas that you need to use. All right, so the moles would be 0.454 moles. And that's moles of CO2. So those are two where we're using stoichiometry in the process of finding a reactant or product. But we're also using the ideal gas law in which to convert it at a certain temperature, pressure that we need to find. So, okay, and I won't give you any extra problems or do. I can let you guys finish that assignment and work on that. Don't worry about doing any problems with this here for today. We'll combine it with some of the stuff we'll do Monday or Tuesday. But that activity might have you do, I think will be pretty good. I think it's one that'll be a good challenge for you guys to do.
Oh, geez.
No, it'll be a fun challenge though. It'll be a fun challenge.